Hello, future doctors. Welcome back to our chemistry series for Neet 2025 and 2026. I'm Chongtham David, and I'm excited to continue this journey with you. In this session, we'll explore the fascinating world of alcohols, phenols, and ethers. So, let us solve 45 important questions that will strengthen your understanding and boost your confidence. Stay focused, ask questions, and remember every concept you grasp is a step closer to your medical dream. As Einstein wisely said, the important thing is not to stop questioning. Curiosity has its own reason for existing. So let's keep that curiosity alive and make learning chemistry an enjoyable experience. So now let us dive in to the first question. Now let us read the question. Question number one. Yeah. Diethyl ether reacts in spite of its usual inert nature with option number one. It says dilute sulfuric acid. Option number two. B. Dilute sodium hydroxide. Option C. Boron trifluoride. Option D. Metallic sodium. The boron trifluoride being a Lewis forms adduct, which is addition product. When I say adduct, it is addition product. In short, we call it adduct. Okay. So boron trifluoride being a Lewis acid because it is electron deficient species, right? It forms adduct, addition product with diethyl ether, which is C2H5OC2H5. We call this oxygen ethereal oxygen. So being a Lewis acid, it can accept electron, and after combining with this ethereal oxygen from diethyl ether, it can form adduct, which is called addition product. Okay. So which is the Lewis base? If this BF3 is your Lewis acid, I'm going to write here La for Lewis acid, and this is your Lewis base. So from your foundation concept in class 11, you have learned electron donors are Lewis base, electron acceptor are Lewis acids. So conclusion can be drawn from this. Diethyl ether reacts in spite of its usual inner nature with boron trifluoride. This will be the answer. Next question, question number 2. N-propyl alcohol and isopropyl alcohol can be chemically distinguished by which of the following reagent? So in option A, PCl5, reduction method. C, oxidation with potassium dichromate, K2Cr2O7, and either by ozonolysis. So remember, primary alcohol on oxidation gives aldehyde, which on further oxidation gives carboxylic acid. See, that is the general rule of the thumb. Okay, primary alcohol gives aldehyde on oxidation, and further oxidation generates acid. But the thing is, this should be your primary alcohol. Okay, so remember again, primary alcohol on oxidation gives aldehyde, which on further oxidation gives carboxylic acid. Whereas this aldehyde will change to ketone. Okay, it is going to change to ketone only when the alcohol is no longer primary. If this is secondary, it is changed to ketone, not aldehyde. So from this, you can easily answer the question. The question gives you N-propyl alcohol and isopropyl alcohol. Remember, this N-propyl alcohol is your primary alcohol. So it will change to aldehyde and change to carboxylic acid. Whereas isopropyl alcohol, if you would like to draw the structure of isopropyl alcohol, it will be like this, because this is your secondary carbon. And remember, I have explained before that secondary alcohol on oxidation gives rise to ketone. So this is your propanone. So the answer will be C. Next, question number 3. Which of the following reaction will not result in the formation of any sol? Option A, phenol plus dimethyl sulfate. B, sodium phenoxide with methyl iodide. C, diazomethane reaction with phenol. D, reaction of Grignard reagent with phenol. C, alkyl magnesium halide is Grignard's reagent. So question number 3. Remember, phenol have acidic hydrogen, active acidic hydrogen. So it reacts with this Grignard reagent. The reason being, phenol has active acidic hydrogen. So you know the formula of phenol, C6H5OH. Or even you can write like this with the help of the benzene ring. So either way, this is phenol. So phenol, when treated with methyl magnesium iodide, methyl magnesium iodide is your Grignard's reagent. Remember, I have explained before, phenol has active acidic hydrogen. So it reacts with this Grignard's reagent, methyl magnesium iodide, to give your methane. Okay, not any sol. This will go as methane. So you know the formula of methane, Mars gas CH4, and this will not give your product, that is any sol. And the addition product, or you can say the byproduct, will be C6H5O MgI. So the correct answer for this will be reaction of methyl magnesium iodide with phenol. Question number 4. Let us see. Intermolecular hydrogen bonding is strongest in. You know, hydrogen bond is formed between electronegative species and hydrogen. And hydrogen bonding is formed in compounds in which this hydrogen is attached to highly electronegative species. In the p block elements, you have group 17, group 16, and 15. I call it phone. Go backward, you have phone. The halogens, the chalcogens, the nicomides, the nicogens. So when you combine this, you can say these are electronegative, highly electronegative elements. In the Pauling scale, you have the electronegativity value of fluorine the highest, 4 something. Then subsequently it keeps on reducing along the period. That is from right to left side. So phone, or you can say nitrogen, oxygen, fluorine, fluorine, oxygen, nitrogen. These are electronegative species. They want to combine with hydrogen and form hydrogen bonding, right? So which must be the answer for question number D? If you observe carefully the structures, methanol will have the highest tendency to form hydrogen bonding. Let us draw the structure of this methylamine. CH3, NH2, phenol. You have to check their bonding structure. Formaldehyde, and last of all, methanol. Okay. In formaldehyde, oxygen is not having hydrogen atom, so it shows very little hydrogen bonding. Can you go back like this? This is your formaldehyde. Nitrogen is less electronegative than oxygen, so hydrogen bond formed by amines will be weak in comparison to alcohol. You can see this train which I have given here, phone. And phenol forms weak hydrogen bonding due to steric hindrance due to this bulky phenyl group. Okay. So the answer for this question, the strongest, will be shown by methanol. Let us see question number 5. It says, what is the formula of vinyl carbinol? Okay, since this chapter is from alcohol, phenols, and ethers, you're asked to find the formula of vinyl carbinol. Methyl alcohol, or you can say methanol, is also known as carbinol. Remember, CH3OH. Commonly we call this carbinol. From this you can derive the vinyl carbinol. So, allylic, vinylic carbon. This must be your vinyl carbon. And you have the methanol part. This is your vinyl carbinol. And carbinol is nothing but your methanol. So finally you have vinyl carbinol as CH2 double bond CH, CH2OH. So the answer for this question is most close answer will be option A. Okay, this is the correct answer. Coming to question number 6, Lucas reagent. Easy question. The formula of Lucas reagent. I hope everyone can answer this question. Yes. Lucas reagent is a mixture of concentrated hydrochloric acid and anhydrous zinc chloride. So option A will be the correct answer. Good. Question number 7, let us see. It asks you the order of reactivity of the following alcohol towards concentrated hydrochloric acid. We are given some structures here of alcohols. You have primary, secondary, tertiary. Remember the stability of the intermediate carbocations. Remember that the presence of electron withdrawing group intensifies, that is, destabilizes the carbocation. So I can rewrite the structures from the alcohols in option in figure 1, 2, and 3, and 4 as such. Remember, the order of reactivity depends upon the stability of the carbocation. So I have drawn the carbocation of structure number 2. It generates secondary carbocation. And another structure of carbocation, structure number 2 here, fluorine. Sorry, this must be fluorine, okay, not iodine. This is from structure number 1, and this is from structure number 2. Still you have secondary carbocation. And from structure number 3, you will now have another carbocation. This is also secondary. Let us see what kind of carbocation this structure number 4 generates. From structure number 4, you will generate primary carbocation. So this is from structure number 4. This is the most stable benzyl carbocation, or you can write it in forms of ring. So as I have told you, remember that presence of electron withdrawing group intensifies or destabilizes the carbocation. Thus, structure number 1 and structure number 2 are less stable than structure number 3 because the presence of electron withdrawing group EWG intensifies and destabilizes the carbocation. Right? So further, structure number 1 generates this secondary carbocation, which I've shown you here. This one. Okay. So this is less stable than structure number 2. I'm going to change the color to black. This is from structure number 2. Okay, let me write here structure number 1. This carbocation comes from structure number 2. This comes from structure number 3 from 4. You have to make the ascending order or descending order of their reactivity. So structure number 1 is less stable than structure number 2 because of minus inductive effect, which is more pronounced in structure number 1 due to less distance between the fluorine and the positive charge. See the distance? Fluorine and the positive charge. Fluorine and the positive charge. Clear? Yes. Thus, the stability order of the 4 carbocations and their reactivity of their parent alcohols. You can now generate the sequence. Yes, you can observe from the carbocation, it goes 4, 3, 2, then 1. See, all this logical explanation comes from the presence of EWG group. It intensifies, that means it destabilizes the carbocation, and the order of reactivity towards concentrated HCl will follow 4, 3, 2, and 1. So which is the correct answer? C. 4, 3, 2, 1. Let us now move on to question number 8. What is the major product of AM in the following reaction? Look at the reaction. You have para-bromotoluene in reacting with benzoyl peroxide. Carbon tetrachloride is the solvent, NBS. When treated with this para mixture gives X, and again treated with sodium ethoxide in alcohol gives M. Question is asking you find M. That is the major product M. Now let us try to write the reaction so that we can answer this question. Para-bromotoluene. You add all this reagent NBS peroxide, benzoyl peroxide in organic solvent, carbon tetrachloride. When you heat this, okay, because question is giving you the reaction, after heating this, there will be allylic bromination, okay. From this NBS, there will be allylic addition reaction. The substitution reaction causes hydrogen to leave, then bromine will come here, and it now forms allylic bromination. Now you have this reagent, second reagent, you add it again to this mixture so as to form the major product M. So after adding this sodium ethoxide in the presence of alcohol, or you can say ethanol, you will now have the final product M. So this will be the answer, right? Option number uh, B will be the correct answer for this question. Question number 9. Epichlorohydrin is in option A 3-chloropropane, 3-chloropropane 1-ol, 3-chloro 1,2-epoxypropane. None of this. Question number 9, let us see. So you try to write the structure. This is a common name. Epichlorohydrin is a common name of 3-chloro 1,2-epoxypropane. Okay. So when you start naming, you go from this carbon 1, 2, 3. So how to name this? Start counting from this substituent, which is present in carbon number 3. 3 chloro 1, 2. This is the epoxy part. Okay, so we call it epoxy propane, and commonly we call this epichlorohydrin. Right, question number 10. So the answer for question number 9 will be option number C. Question number 10. Ethanol can be converted into ethanaldehyde. This is second primary alcohol. On oxidation, it can easily change to aldehyde. So it will be option number C. You can call this PCC. One of the reagent to change to aldehyde. Question number 11. In Williamson synthesis, if tertiary aryl halide is used, tertiary aryl halide is used, then ether is obtained in good yield. In poor yield, alkene is the only reaction product. In option D, it says a mixture of alkene as a major product and ether as a minor product forms. So you should remember Williamson synthesis, which you've learned in class 12. It's there in your NCRT text. Don't forget to complete NCRT first. That's the first thing, first step of your preparation for this exam. So let us write this reaction. A tertiary aryl halide is used. So this is your tertiary halocane plus sodium methoxide. Since this is electronegative polar state. Okay. Now alcohol will be removed after treating this tertiary halocane with your sodium methoxide. So now let us see the product that is likely to be formed after removing this bromine. Double bonded carbon will come here. A salt will be removed, sodium bromide. The product will be 2-methyl propene and 1 alcohol. So if a tertiary alkyl halide is used and alkene is the only reaction product and no ether is formed, for example, I have given you this reaction of the sodium methoxide with tertiary halocane. It gives exclusively this 2-methyl propene, right? Methyl is a substituent. See, it is because alkoxides are not only nucleophiles but strong base as well. They react with alkyl halides leading to elimination reaction. This is elimination reaction, Williamson synthesis. So alkene is the only reaction product. Answer the question. 11 will be option number C. Clear? Now let's move on to question number 12. Right, denaturation of alcohol. What is denaturation of protein? You have learned, right? Losing of biological activity. Now don't get confused with that. The same way denaturation of alcohol is. It is a commercial, when commercial alcohol is made unfit to drink, okay, by adding some salt like copper sulfate to change the color, or they have a foul smell by addition of pyridine, That kind of thing we call it denaturation of alcohol. So look at the option: mixing of copper sulfate to give color and pyridine, a foul smell. This is called denaturation, making unfit to drink. Right. Question number 13. 2-phenyl ethanol may be prepared by the reaction of phenyl magnesium bromide. This is your Grignard's reason again. Right. So 2-phenyl ethanol, which is a primary alcohol, can be prepared from the given Grignard reagent by treating with ethylene oxide. Let us write the reaction first. You know, Grignard's reagent C6H5 MgBr. Get here. Okay, let's see the question. This is phenyl magnesium bromide reacting with your ethylene oxide to give rise to C6H5 CH2. But if I treat this same Grignard reagent with formaldehyde, C6H5 MgBr, 1% is called formalin. Now I'm going to generate alcohol. This is your alcohol, CH2OH. Yeah. So 2-phenyl ethanol, this one, which I've drawn here, it is a primary alcohol. They can be prepared from ethylene oxide. This is primary. So the answer for this question will be epoxide. Question number 14. Arrange the following in increasing order of their acidity: orthocresol, salicylic acid, phenol. Orthocresol is option A. No, it's A. Salicylic is B. Phenol is C. You have to remember electron releasing groups like methyl, methoxy. Let me write here. These are all electron releasing group. They have plus I effect. Okay. These electron releasing groups intensify the negative charge of phenoxide ion. That is, destabilizes, it enhances, or it decreases the ionization of this parent phenol. Therefore, decreases acidity, while electron withdrawing groups increases acidity. So what are electron withdrawing groups? Or you can say minus I effect. You have nitro, carboxylic acid, all the carbonyl compounds. Okay, minus I effect. So based on this, you know the structure of cresol in the para position. In the ortho position, you have CH3. This is cresol, and salicylic acid. In the ortho position, you have your carboxylic group. This is salicylic acid. If it is salicylaldehyde, this will be CHO and phenol. See, the substituents attached. This is acid. This is your methyl part. This one is methyl group plus I effect. Will be shown here, carboxylic acid minus I effect. So you can easily answer the question. The sequence will be cresol. This is cresol. This is salicylic acid B, and this is your phenol. The sequence will be plus I effect showing cresol less than phenol, then last of all is salicylic acid. So sequence will be A, C, and B. A, C, and B. So option number D will be the correct answer. 15. Which of the following is most reactive towards aqueous HaloSH HBr, hydrogen bromide? Here you have to remember carbocation will be formed, okay? In question number 15. So let us see what are the product which can be formed from these given options. Benzyl carbocation may be generated, which is the strongest and it is the most stable, followed by a secondary carbocation generated from the given alcohol, and last of all, primary. I've already explained this before. Primary is the least stable carbocation. This is the primary carbocation. This is the benzyl carbocation. So the species capable of forming most stable carbocation will be the most reactive. So this benzyl carbocation, it is generated from one phenyl, one propanol. So initially here there will be one OH group, but it has changed to carbocation. So this must be the most stable product. And this one secondary, this is generated from two propyl, this one, and this one is from three phenyl, one propanol. All are equally active, will not be the answer. 3 is also ruled out. The answer will be A, which is benzyl carbocation. Clear? Question number 16. Let us see. The ionization constant of phenol is higher than that of ethanol because phenoxide is bulkier than ethoxide. It is stronger than base than ethoxide. It stabilizes through delocalization. Phenoxide is less stable than ethoxide. So you should draw the resonating structure for this. So learn to ionize phenol by treating this with water. Changes readily to phenoxide ion. Now resonance will take place because it's acidic, it gives out proton. Learn to draw this resonating structure. This will have a lot of electron here, minus charge, gives one electron here. This will go back. So no need to write all the resonating structure, but still, for those who are new, you can keep on practicing. Minus will be localized at this carbon number 2, double bond. It will carry partial positive charge. Yes. This needs a lot of practice. Minus, then double bond, oxygen. Then this minus will come here. This will go back here. Double bonded carbon here, oxygen will be negatively charged here, minus. So it keeps on going. Okay. So finally, you will have the resonance stabilized phenoxide ion. So resonance hybrid will be something like this. Delta minus is localized at ortho and para position. So this, since the negative charge is delocalized in the benzene ring, it is a stabilizing factor in the phenoxide ion. And because of this reason, ionization constant of phenol is higher, whereas no resonance is possible in alkoxide, that is RO minus, which is derived from alcohol, not phenol. So the negative charge is localized on oxygen atom in case of alcohols. So answer for this question will be C. Simple reasoning can be based on resonance. Clear? Question number 17. Rectified spirit is a mixture of. This is a mixture of 95.87% ethyl alcohol and 4.13% water. Option D. Ethanol is prepared industrially by which of the following reaction? Let us see. It can be prepared by hydration of ethylene or fermentation of sugar In olden days, people used to make grape wine, bananas. They are a good source of carbohydrate. When it undergoes fermentation, you can generate ethanol. Right, question number 8. Let us see. This is ethene. When this is treated with acid, I will write as sulfuric acid in this way because it can ionize in solvent. Now addition product is formed from this. You have to boil with water by heating, and after boiling changes readily to alcohol. Then this region goes back as dilute sulfuric acid. Now fermentation of sugar is another process. The first step I've done here is from preparation of alcohols from alkenes. This you will find in the preparation part of alcohol. You will find this in your NCRT text as well. And the second step is either by fermentation of sugar, cane sugar, which is a disaccharide. Saccharide comes from the Greek word saccharin, which means sweetness. After adding the enzyme invertase, see enzymes and catalysts, they behave in similar function. Okay, they lower the activation energy, then enhance the rate of reaction. Right. So after hydrolysis of this disaccharide, it gives glucose and fructose. These are monosaccharides. They are isomers, but they have different functional group. One will be fructose will be having ketonic group, and glucose will be having a aldehyde group. Glucose and fructose. But our target, our mission is to generate alcohol. So from this, after adding your amylase enzyme, you will generate two molecules of alcohol. Now, in either way, either by hydration or fermentation of sugar. So the question will be, the question is asking, ethanol is prepared industrially, that is in large scale by both of the method. But most common one is the second method, fermentation process. I hope it's clear. Question number 19. Mechanism of acid catalyzed hydration reaction involves. This is also concept based question, easy question. Just learn to remember all those basic things which you have learned in your NCRTs. Now let us say hydration of alkenes. When protonation of alkene takes place, it forms carbocation. Okay, by the electrophilic attack of hydronium ion, which can be generated by addition of acid to this water molecule. It gives your hydronium ion. See, remember, hydrogen ion doesn't exist alone. It exists in collaboration with water because the size is less than 1 Fermi, which is impossible. So in association with water molecule, hydrogen combines and forms hydronium ion. So they are used synonymously. So this is the first step, let us say. In the second step, all right, before coming to the second step, this is going to act as electrophile. It is electron deficient. Now on alkene, which has a double bonded carbon, it has electron rich system, so it is now going to attack this electron deficient species. So when this double bonded carbon wants to take this hydrogen, this bond will go back, and now it generates a carbocation like this plus water. This is the first step. Step number 1. Step number 2 is the nucleophilic attack of water on carbocation. On this carbocation, water, since it is present in abundance in the medium, it is still present as H2O, and this is the nucleophilic attack of water on this carbocation. It is going to form an intermediate species. O plus. This is not stable, so it can go back and go as water. So let me rewrite this structure. Sorry, you have to write this plus charge. Now water again attacks on this hydrogen. Okay, and this bond is going to be given to this electron deficient oxygen. So now you have alcohol by removal of this hydronium. OH plus, this is the mechanism, basic mechanism. So deprotonation to form alcohol will be the correct answer. Question is asking mechanism of acid catalyzed hydration reaction involves. Okay. Next, question number 20. Match the column. Methanol. Okay, there are two column. Column 1, let us try to match correctly. I will change this color to green. Methanol. A will be wood spirit. Coal-based reaction involves conversion of phenol to hydroxysalicylic acid. And Williamson synthesis, reaction of alkyl halide with, we have done this before. D, conversion of secondary halocane or secondary halide alcohol to ketone by heated copper at 573 Kelvin. So question number 20, if you match correctly, the answer will be C. A2, B1, C4, D3, right? Let us move to question number 21. 100% alcohol is also called absolute alcohol. It is prepared by distilling rectified spirit over. So find the correct answer. I will explain here by giving you one reaction. Okay. This is your magnesium ethoxide. Since magnesium carries it is a divalent cation, I'm writing here 2. When I treat this with water and undergo distillation, that is boiling, now you will find that there will be two liquid mixture separated. One is a distillate. Okay, this is called the distillate, which is the one which boil first, and magnesium hydroxide, it is your residue. To balance this, you can put here 2. So this is the process, okay? How absolute alcohol is prepared by distilling rectified spirit. Answer will be magnesium ethoxide. Question number 22, read carefully. Paracresol, you know the structure of cresol. Paracresol reacts with chloroform in an alkaline medium to give the compound A, which adds hydrogen cyanide to form compound B. The later on acidic hydrolysis gives chiral carboxylic acid. The structure of the carboxylic acid is. So write the structure of cresol. The para position, you have this hydroxy group. When this OH is replaced in the presence of chloroform, CHCl3 plus sodium hydroxide. What reaction is this? I think this is familiar. call it the Reimer-Teyman reaction, right? Reimer-Teyman reaction takes place. That means the structure will be now OH. At this position, you will now have the aldehyde part. Further react with hydrogen cyanide according to question. You will now generate, this is carbonyl compound. Reaction with hydrogen cyanide gives cyanohydrin. Remember, cyanohydrin forms when HCN reacts with this carbonyl group. CN comes here. Then again, treat this with water molecule. Finally, you will have the structure of the product. I hope you're not feeling tired. We are already in the middle of the journey. Okay. I hope you're all keeping up with me. OH, this will be the final product. So according to the option, you find out the correct answer. This will be most likely para-hydroxyphenyl hydrochloric acid. Okay, option number C. Let's see question number 23. Which of the following will show the highest pH value? Question number 23. You have to answer this based on resonating structure as well as the one which shows minus I effect. See, in case of meta-nitrophenol, operational effect of this nitro group is electron withdrawing inductive effect. While in the case of para and orthonitrophenol, both will have minus R and minus I effect. They are operational in option B and C. So you have to answer this meta. Okay, this is based on operational effect of nitro group, which is electron withdrawing group. Meta-nitrophenol will show the highest pH value. So in case of meta-nitrophenol, operational effect of this nitro group, it is going to be electron withdrawing group. Okay, electron withdrawing, or you can say inductive effect. While in the case of B and C, both are minus R and minus I effect, which are operational. So correct answer is M. This will show the highest pH value. Remember pH again, it is defined as negative log of hydrogen ion given by Sorensen. Question number 24. Which of the following compound is resistant to nucleophilic attack by hydroxyl ions? So you're given different types of compounds here: methyl acetate, acetonitrile, acetonide, diethyl ether. So 24, let us see the structures. First, let us write the structure of methyl acetate. Minus, and this will be plus. Okay. Initially there was double bond. It goes to this oxygen. It now becomes polar. Then acetonitrile will be carbon triple bond. Here plus, more electronegative is nitrogen. Then acetonide. This is amide. Okay, you will find this in the chapter of amines. Then diethyl ether. You will have ethereal oxygen, which is electron rich. We have already done this by reaction with BF3. It forms at the initial question. Go back and find out. Let's see the answer for this question. See, in diethyl ether, it is a Lewis base and it is not attacked by nucleophile, while all the others contain electrophilic carbon. Hence, they're attacked by nucleophiles like OH, or you can say hydroxide ions. So D will be the answer. That is diethyl ether. Clear? Let us see question number 25. Yeah, this will be a little weird. Yeah, name itself is scary, right? Jerry I can't even spell correctly. Jerry determination of active hydrogen in a compound is based upon its reaction with. You're given sodium, Grignard's reagent, zinc, and aluminium. So, number of active hydrogen in a compound corresponds to the number of moles of methane evolved per mole of the compound. That you should know. So I'll give you some of the functional groups like amide, thiol. When sulfur is present, thiol will always be there in the naming part. Alcohol, they belong to the same group, sulfur and oxygen. This is thiol, this is alcohol, or even alkynes, triple bond, right? So when these are treated with your Grignard reagent, let me give you one Grignard reagent, methyl magnesium iodide. Okay, what will be formed here? You are going to generate methane. So Jerevitinov's determination of active hydrogen is based upon its reaction with this Grignard's reagent, methyl magnesium iodide. Right. Next, question number 26. Williamson synthesis is used to prepare, we have done this before, diethyl ether. You can write the reaction if you want to. C2H5Br. This is your ethyl bromide on treatment with sodium ethoxide. Here, removal of product, sodium bromide, and diethyl will be formed. This is your Williamson synthesis. It is not PVC, it is not bakelite. These are all out of the box. They are from polymers. It is not acetone. The answer will be 26B. Question number 27. Which of the following statements are correct? Let us answer this. Remember, methanol poison patient is treated by giving intravenous injection. Okay. Say someone drinks alcohol and suddenly they are brought to the casualty or hospital. You know what the doctors will give as first aid? They are going to be given intravenous injection of alcohol, that is ethanol. So the correct answer will be excess methanol in the body may cause blindness. Okay. So which is the correct answer? Ethanol mixed with methanol is called denatured alcohol. Yes. When this methanol is denatured, the patient may be saved. Question number 28. In the following sequence of reactions, ethanol changes to P, changes to A, B, C, D. Sequence of reaction. So you need to find uh, D, right? I'm going to change this question. This has some defect. P is not the product. This is your phosphorus in iodine. So when ethanol is treated with phosphorus in iodine, it changes to A. And there's some missing points. Magnesium in ether, you can say. Or B, again, you have to treat this with formaldehyde. And C, treat this again with water. So these are some of the missing reagents. Now let us see when ethanol is reacted with phosphorus and iodine. So this is the preparatory part of haloalkanes. Ethanol, when treated with phosphorus and iodine, you will form haloalkane. Name of this haloalkane, anyone can answer this? This is called iodoethane. Magnesium in ether. This will give you your Grignard reagent. Then again treated with carbonyl, that is aldehyde, metformaldehyde. You will get addition product by removal of water molecule. Water will not ride in the product. It goes as CH2, CH3. Then now it changes to propanol, OH. So this will be the name of the alcohol. What will be the name of this alcohol? D. D will be alcohol. How to name this? This is a straight chain hydrocarbon. So N-propyl alcohol. You can simply call it propane 1-ol, does it not? N stands for normal or straight chain. Question number 29. When wine is put in air, it becomes sour due to, it is due to oxidation. Wine is what? Basically, it is your primary alcohol. Okay, it becomes sour because primary alcohol can change to aldehyde, then change to acid. Vinegar, vinegar is sour. Question number 30. Which of the following diol would cleave into two fragments with per iodic acid? Question number 30. Let us learn to write this structure. CH3. We are first writing the formula of hexane. Hexane will have 6 carbon. CH2, CH3. Suppose if I write in the position number 3 and 4, this is your hexane 3,4 diol. When this is treated with CHIO4, gives you 2 molecules because this will become symmetrical. So 2 equal fragments of aldehyde is formed. Option number D. The major product of the following reaction is question number 31. Let's write this heterocyclic structure where this oxygen has electron rich. Let us see the resonating structure of this compound. Anhydrous means there is no water molecule. Okay. Question is saying anhydrous. In the acidic medium, it is now undergoing resonance. This electron, this becomes positive. Further write the resonating structure. Now you can put this alcohol. From this, you will get an intermediate. By removal of this acid medium, you are now going to generate an acetal. OCH2, or this is called acetal. Okay, answer option number B. 31, read the question. This is a diol, okay? Thylene, ethane 1,2 diol on heating with, this is not periodic, it is read as per iodic. We have just drawn the reaction per iodic acid, HiO4. Per iodic acid treated with this diols, it gives what? Can answer the question if you have just answered the previous question. We have just seen aldehyde was formed here. This is your per iodic acid. When per iodic acid is reacted with this alcohol, it forms aldehyde. Same thing here. Question number 32. Let us write the reaction. Ethane 1,2-diol. On treatment with this per iodic acid, HiO4, it gives your formaldehyde. I can write formaldehyde as such, but when you condense this, you're going to get the same thing. So remember, 1,2-diols when treated with aqueous solution of per iodic acid give aldehyde. Not that a primary alcohol, not okay. Remember, primary alcohol gives aldehyde, which is formaldehyde. Since in glycol both the OH groups are primary, hence it gives two molecules of formaldehyde as byproduct. Question number 33. Be patient, we are about to finish. Victor Mayer test is not given by Victor Mayer test. It will not be given by this alcohol. You know why? Primary, secondary, tertiary, right? So option A. 34. What is X in the following reaction? X in the following reaction. Now let us rewrite the structure according to the question. I'll choose a different color. Yes. CH3 in the presence of methanol and sulfuric acid. It is changed to this product. Can you identify the name? So what are the reagents that I've added? Methanol and sulfuric acid. So the reagent which is asked according to the question, it will be methanol and sulfuric acid. E. Question number 35. Which of the following pairs of reagent would give 4-methyl-2-pentanol? 4-methyl-2-pentanol. Let us see the probable product. So when this reactant is treated with ethanaldehyde, the product will be 2-methyl-pentanol. This thing you have to first of all uh, calculate in your mind what is the probable product. When you do the counting, 2, 3, 4, 5. So carbon number 2 gets methyl part, 4 gets OH. Name will be according to 2 methyl, 4 methyl. Sorry, done it in the reverse. 4 methyl. This is your functional group, right? So 1, 2, 3, 4. Right. 4 methyl, 2 pentanol. Okay. So option number B. Question number 36. Which of the following cannot be made by reduction of ketone or aldehyde with sodium borohydride in methanol? 36. See, this structure that is 2-methyl 2-propanol. 2-methyl 2-propanol. If I write You can say this is the longest parent chain. 2-methyl 2-propanol. 1, 2, 3. It cannot be obtained by reduction of an aldehyde or ketone with sodium boride because this is already secondary alcohol. So the answer for question number 36 will be D. Osmium tetraoxide, you know the formula, is a reagent used for hydroxylation of olefins, alkenes, okay, to give diols. Easy. 38. The reaction of sodium ethoxide with ethyl iodide to form diethyl ether is termed as. See, reaction of sodium ethoxide with ethyl iodide to produce diethyl ether is known as Williamson synthesis. Right? We have done this 2 questions previous. So it is a nucleophilic substitution reaction and proceeds via substitution nucleophilic bimolecular. So B is answer. 39, you can do this by yourself, I think. The IUPAC nomenclature of this compound will be, you do the counting. So when you numbered to the lowest set of Locandrol, according to that rule, when you do the numbering, you have to go from left side 1, 2, 3, 4, 5. So what must be the name of this alcohol? It should be 2-methyl 2,4-pentadiol. So option number B is the correct answer. Question number 40, same question. This will be done by you and give the answer in the comment section. Question number 41. Aspirin is an acetylation product of, question number 41, orthohydroxybenzoic acid. Question number 42. Acetic anhydride reacts with diethyl ether in the presence of anhydrous aluminum chloride to give. Write the reaction and answer the question. So you write the ether, diethyl ether can also be written as, within the outside the bracket you write the ethereal oxygen, and acetic acid anhydride. You can also say this acetic anhydride. By treating these two mixture in the presence of anhydrous aluminium chloride, ester can also be formed. Alkyl alkanoid. So this is your ester. So likely the answer of the option C. Right? Let us move to the last 3 questions. We are left with only 3 questions. Question number 43. Formation of which compound given below form 1-butanol needs an oxidizing agent? Can you answer this? 1-butanol. This is a primary alcohol. Butane means 2,4 carbon. Butanol, oxidation. I've explained this before. Very important. Primary alcohol oxidation change to aldehyde, which can further change to acid. This is your butanaldehyde. 43 will be B, right? Same. 44. Orthoxylene when treated with, so you must know what is xylene. Okay, in the para position of benzene ring, initially you have toluene, methyl benzene. If this is in the carbon number 2, you have ortho, 3 meta, 4, it will be para. Anyway, if both of these are in the same adjacent group, you have ortho xylene. Now ortho xylene treated with nitric acid means this is a strong oxidizing agent. It undergoes oxidation. Addition of this nitric acid causes formation of carboxylic acid, phthalic acid. Remember Gabriel phthalimide synthesis. Now this will change to phthalic anhydride on heating. Okay. phthalic anhydride. Only one oxygen is the bridge. And this phthalic anhydride is your X, according to the question. Read carefully. Now, if this is changed to, if this is made to react with phenol in acidic medium, what is the acid given to you? Sulfuric acid. See, sulfuric acid is given in this acidic medium. It now changes to an indicator, phenolphthalein. Right? This is the answer for the question. Why? Why is what? Phenolphthalein. Last question, number 45. Which of the following upon treatment with tertiary sodium butoxide followed by addition of bromine water uh, decolorize the color of bromine? Bromine is yellowish brown liquid, right? So it decolorizes. Tertiary sodium butoxide is added to this. Bromine water is decolorized. Tertiary sodium butoxide. So what must be happening in this reaction? You will now find the color. It fails to the question is saying, you can see, fails to decolorize. Okay, it's written fails, and the screen is small. It is not seen clearly. I'll reread the question for you. Which of the following upon treatment with tertiary sodium butoxide followed by addition with bromine water fails to decolorize the color of bromine? So when you write the reaction, this will change to tertiary butyl. Okay. This will fail to decolorize the color bromine due to unsaturation. Right. Now the answer for this question will be option number A. Thank you.